Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the edge of something vast, strange, and gently unsettling. What would it truly take to destroy our entire planet? But, before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the fragile heart of our planet, and what it might take to bring that heart to a stop. You live on a remarkably stubborn little sphere. It spins, mostly quietly, through the soft dark of space, orbiting a sun that bathes it in light, sometimes too much, sometimes not enough, but just enough to allow life to bloom. And yet, for all its beauty, the oceans that whisper to the coasts, the air that carries the scent of bread or rain, Earth is also incredibly destructible. Not easily, of course, but not impossibly either. To destroy a planet sounds like the stuff of science fiction, something reserved for cosmic villains or intergalactic empires. But real scientists, in real labs, have spent time asking, what would it take? And more quietly they ask, how close have we already come? Destruction can mean many things. You could vaporize Earth entirely, reduce it to gas and dust that would scatter into the dark like smoke. Or you might just sterilize it, leaving the rock intact but scrubbing every trace of life from its surface, like a child knocking all the crayons from the table but leaving the desk untouched. Or maybe you wouldn't need to kill it at all. Just change its orbit slightly, or turn off its magnetic shield, or let its ocean slip away. Each path is different, but each could end the world in its own slow, spectacular way. But even that idea, end the world, isn't always as apocalyptic as it sounds. Earth has already ended in small ways many times. The oxygen we breathe wasn't always here. Dinosaurs once ruled, then disappeared. The continents have danced across the globe like slow-moving puzzle pieces for billions of years. At least 5 mass extinctions have swept over this planet like waves. Each one terrible, each one leaving just enough life behind to start again. Still, none of those events, not the meteor that ended the age of reptiles, not the volcanic winter that chilled the world into silence, none of them truly destroyed Earth. Life found ways to crawl back. The atmosphere rebalanced. The seas softened the edges of extinction. In the quiet, language of time, the planet has always whispered, not yet. But what if? What if the next catastrophe doesn't whisper, but shouts? There are 2 kinds of forces that might end everything. One comes from out there, the cold indifference of space. Giant rocks, black holes, distant stars dying with terrible grace. The universe is not malicious, but it is restless. Its beauty hides great violence. The second kind of threat comes from in here, from us. Our cleverness, our machines, our willingness to press buttons before we fully understand what they do. And then, somewhere in between, are the slow burn threats. The changes we don't notice day by day. The warming oceans, the weakening fields, the subtle ways our world is rearranging itself while we're busy checking emails. We'll visit all of them, softly, gently, over the next couple of hours. We'll look at black holes not as monsters but as strange teachers. We'll talk about intelligent machines not with panic but with curious caution. We'll watch the sun swell in slow motion, and we'll pause often to remember, you are still here. The Earth is still whole. And tonight at least the world is quiet. There's no need to understand everything. You don't need a physics degree to walk this path with me. If a phrase doesn't make sense, let it go like a leaf in a stream. We'll circle back, or we'll let it drift. The point isn't to worry, It's to wonder, to float just for a while in the odd beauty of fragility. Because even if none of these endings ever arrive, even if we never see a black hole, or trigger a grey goo apocalypse, or watch the oceans rise past our knees, there's something humbling, almost comforting, in knowing how delicate things really are. It reminds us to be careful, and to be grateful, and maybe to pause sometimes and look up, not in fear, but in awe. So here we are, floating on a pale blue dot that's very old, very small, and very special. And for the next little while, we're going to explore what it means to be just this close to not existing. Not to scare ourselves, but to deepen the wonder. The way you might hold your breath before diving under calm water, just to feel how much it means when you come back up. Let's begin. Let's linger for a moment on Earth itself. Not its storms or cities or roaring volcanoes, not yet. Just the planet. Quiet, round, turning slowly in space like a marble held in a beam of sunlight. From space, it's hard to imagine anything about Earth as vulnerable. Against the black, the blue and white sphere seems perfect. Whole, complete. But up close, you begin to notice it's not invincible. It never was. To understand what it means to destroy the Earth, we first need to consider what it actually takes to keep a planet like this together. And the answer is surprisingly delicate. Earth is the result of countless coincidences layered atop one another like geological sediment. Its orbit is just the right distance from a not too hot, not too cold star. It spins just fast enough to spread heat, but not so fast that it flies apart. It has a magnetic field strong enough to block solar radiation, an atmosphere thick enough to hold in warmth, and oceans vast enough to regulate its moods. All these elements, stable orbit, liquid water, moderate gravity, work together like the pieces of a finely tuned mobile. Tug one too far and the balance tilts. Pull hard enough and the whole thing collapses. Now, let's be gentle but curious. What would it take to actually undo Earth? If you wanted to vaporize it completely, erase every atom, you'd need to overcome something called gravitational binding energy. That's the total energy holding all the planet's pieces together. Imagine the Earth made of countless Lego bricks. To disassemble it brick by brick and toss them so far apart that they never reassemble. That's the energy you'd need. And the number? About 2.24 times 10 to the 32nd joules. That's a lot. About a week's worth of energy from the entire sun. Not sunlight reaching Earth. The whole sun. You'd need something truly apocalyptic to make that happen. A weapon of pure antimatter maybe, or a collision with a star. Even then, you'd be vaporizing more than just rock. You'd be rewriting the very presence of a planet. But that's the extreme. Most scenarios that would end the world don't go that far. They don't need to. Ending life is much easier than ending mass. To sterilize the surface, to wipe out every organism, every tree, every coral reef and insect and bacterium, you'd need far less energy. A gamma ray burst from a dying star could do it. So could a runaway greenhouse effect or a self-replicating nanobot swarm. The rock would remain, but everything soft, everything breathing, would be gone. Then there's a subtler kind of destruction. You don't have to burn a painting to ruin it. Sometimes, all it takes is a single brushstroke in the wrong place. Likewise, Earth could be thrown off balance with something as simple as a nudge in its orbit. Let's say, hypothetically, we could guide a massive asteroid very carefully so that it passes near Earth at just the right angle. It doesn't hit us. It just pulls, ever so slightly. Over time, enough of these gravitational assists could shift our orbit closer to the Sun, just a little. But even a small change in distance could wreak havoc. Temperatures would rise, oceans would warm, ice would melt, and eventually we'd reach a tipping point where Earth begins to cook itself. It's all theoretical, of course. No one's suggesting we start flinging space rocks. But the point is that Earth's position isn't etched into the universe like stone. It's more like a leaf on a stream, steady, yes, but movable. Disturb the stream, and the leaf goes somewhere new. Now, let's return to that shimmering concept of antimatter. It's a real thing, not just science fiction. Every particle of matter has an opposite, an antiparticle. When they meet, they annihilate each other, releasing pure energy. Beautiful, yes. Dangerous, definitely. In theory, if you gathered enough antimatter, say a few dozen kilograms, and brought it into contact with the same amount of matter, you could release more energy than the largest nuclear weapons combined. But here's the calming truth. We can't do that. Antimatter is extremely hard to create and even harder to store. At CERN, one of the world's most advanced particle labs, scientists can produce it, but only a few atoms at a time, and even those disappear almost instantly. It's not a practical doomsday device. Not yet. Perhaps not ever. But imagining it helps us understand just how much power is locked inside the simplest things. An electron, a proton, a bond between atoms. It also reminds us of how fragile we are by comparison. We often think of Earth as permanent, immutable, a stage for stories, not a character itself. But Earth is not a stage. It's alive in its own way, breathing through its atmosphere, trembling with plate movements, whispering through magnetic fields. And it can be hurt, bent, tilted, shaken. But perhaps what's most striking is how long it's lasted. For 4.5 billion years, Earth has survived solar flares, asteroid impacts, planetary collisions, extinction after extinction. It's endured ice ages and firestorms and chaotic periods where its own orbit wobbled like a toddler learning to walk. And through all that, it kept going. It doesn't take much imagination to picture the world ending, but it does take a certain quiet awe to appreciate that it hasn't. You're living on a planet that spins steadily in the black, quietly defying destruction every second of every day. And tonight, that planet is still here, whole, turning, whispering its way through space. Soon we'll leave the gentle ideas behind and explore the wilder ones. Black holes, dying stars, rogue planets. Things so strange, they seem made for bedtime stories. But first let yourself feel the weight of this. Earth exists, still, and somehow, so do you. If you tilt your head back and look into the sky on a clear night, what do you see? Stars, mostly. Perhaps a planet or two if you're lucky, a smudge of the Milky Way if you're far enough from city lights. But what you're really seeing isn't just points of light, it's stories that ended long ago. Explosions frozen in time, distance turned into memory. Light that left its home before your home even existed. And drifting among those ancient songs of fire are dangers, quiet ones, that don't look like monsters at all. They look like stillness, like silence, like the absence of anything familiar. Earth has been remarkably lucky so far. It exists in a narrow slice of space and time where life is possible, and more than possible, thriving. It orbits a stable star. It shares space with planets large enough to act as shields, their gravity pulling dangerous objects away. It has a moon that steadies its wobble and oceans that buffer its moods. But none of this was guaranteed, and none of it is forever. Throughout history, our planet has been bruised by the cosmos. About 4.5 billion years ago, not long after it formed, Earth was struck by a Mars-sized object. Theia, as some scientists call it. The collision was so intense that part of Earth was blasted into orbit, eventually coalescing into the moon. That same impact nearly ended our planet before it began. But instead of destruction, it gave us tides, balance, and a companion in the sky. Much later, roughly 66 million years ago, a smaller, but still terrifyingly large asteroid struck near what is now the Yucatan Peninsula. It carved out a crater over 100 miles wide, set the atmosphere ablaze, and rained molten glass across the world. The sky darkened, plants died, temperatures plunged, and in the chaos, the age of dinosaurs came to a close. That rock was only about 6 miles wide, not much bigger than a small city, but it carried enough energy to change the course of evolution. Now pause with that thought. 6 miles. That's not big in cosmic terms. Earth is 8,000 miles across. The asteroid was less than 1,000th its diameter, a speck. And yet, it nearly reset the planet's biological clock. This should make us pause, not in fear, but in awe. Because space is not just vast. It's not just cold or quiet or indifferent. It is also busy, and it has good aim. Even today, Earth passes through clouds of debris, leftovers from planetary formation, fragments of ancient collisions. Most burn up in the atmosphere, painting soft streaks across the night sky. Shooting stars, we call them, though they are neither shooting nor stars. But some of these visitors are larger, more solid, and sometimes they come close. In 2013, a meteor about 20 meters wide exploded over Chelyabinsk, Russia. The shockwave shattered thousands of windows and injured over 1,000 people. It was small, as far as cosmic debris goes, but it was a reminder. We don't always see them coming. They don't roar or hum. They simply arrive, fast, silent, and full of kinetic potential. Earth is hit by these objects all the time, most too small to matter. But there are hundreds of near-Earth objects we track carefully, like nervous shepherds watching wolves in the dark. And though we've gotten better at predicting orbits and preparing for deflection strategies, the truth is, sometimes we're still just hoping. Now, let's stretch time again, from minutes to millennia. Because not all threats arrive like falling stones. Some unfold over millions of years, like orchestras building to a note you may never hear. The planet's own orbit, for example, is not perfectly steady. It changes shape slightly over long cycles, in patterns called Milankovitch cycles. These cycles influence how much sunlight reaches different parts of Earth, subtly triggering ice ages and thaws. Alone, they're not dangerous, but combined with other factors, like volcanoes or carbon cycles, they can tip Earth into periods of deep freeze or intense heat. There have been times when the Earth was entirely white, not just cold, but covered, pole to equator, in ice. A snowball Earth. Some scientists believe this happened more than once, long before complex animals evolved. The oceans froze almost to the bottom. Glaciers stretched across what are now deserts. Life clung on in cracks and vents, in small pockets of warmth beneath the ice. And then, eventually, the snow melted. Volcanoes released enough CO2 to warm the skies. The ice cracked and withdrew, and with it came a flood of oxygen, a bloom of complexity. The harshest winter gave birth to new life. That's the strange rhythm of Earth's history. Catastrophe and renewal, death and reinvention. The planet doesn't just survive, it transforms. What feels like an ending is often just a deep inhale before a different kind of breath. But there is a line we could cross, a point where destruction is no longer followed by rebirth. If Earth loses too much water, too much atmosphere, too much time, it may become uninhabitable not just for humans, but for life of any kind. It may become quiet in a different way. Not the quiet of sleep or night, but the quiet of nothing growing. A silence that doesn't end. And still the planet might remain, scarred, empty, but spinning. It doesn't take a fireball or a black hole to end a world. Sometimes it just takes forgetting how fragile it is. So when we ask what could destroy Earth, we're really asking something else. What keeps it alive? What balances it, shields it, renews it? And how close are we, really, to letting those things slip away? In the sessions ahead, we'll look at the louder possibilities. Black holes, bursts of light, machines with too much hunger. But before we go there, take a moment to hold the shape of Earth in your mind. Small, blue, spinning, still whole, still here. In the quiet darkness between stars, there are places where the rules change, where light, that fastest of all, travellers slows down, bends inward and disappears, where time itself seems to hesitate, stretch thin and finally stop. These are not loud places. There are no explosions, no sparks, no roaring gravity waves to warn you. Just a silence so complete that even information, even memory cannot escape. These are the black holes, and strangely enough, they are not rare. In the vastness of space, black holes drift like invisible marbles, left behind after massive stars collapse. Some are nestled at the hearts of galaxies, surrounded by orbits of light and dust. Others roam more freely, solitary wanderers, born of ancient violence, now moving without sound through the void. What makes a black hole terrifying is not its speed or aggression. It doesn't chase, it doesn't hunt, it simply waits. And if something comes too close, even light itself, there is no return. Now, despite their mystery, black holes are not infinite. They have mass, they have boundaries. In fact, if you compressed the entire mass of planet Earth into the size of a marble, about 1 inch across, you'd have a black hole. It's not the mass that's strange, it's the density. The closer you get to the centre, the more stretched space becomes. Not metaphorically, literally. If you approached a black hole feet first, for instance, the gravity at your feet would be far stronger than at your head. The difference would become so extreme that your body would stretch and stretch and stretch into something scientists whimsically and somewhat disturbingly call spaghettification. You would become a thread of atoms, unravelling into the fabric of space itself. But don't worry, you wouldn't feel pain, you wouldn't feel much of anything, because time itself would begin to behave strangely. For the outside universe, it might take years to watch you fall, but from your point of view it might happen in a blink, or perhaps not at all. Because once you cross the event horizon, that invisible threshold around a black hole, nothing can get back out, not even signals to say you arrived. That's the terror and the beauty of black holes. Not destruction, but isolation. They don't shatter things, they erase them, and they do it quietly. You might imagine, then, that for Earth to be swallowed by one, it would have to drift too close to a giant black hole in space. But what if, instead, one came to us? There's a concept in astronomy called a rogue black hole. A small one, perhaps just a few times the mass of the Sun, drifting between stars after being ejected from a violent event, like a galactic collision or a supernova gone uneven. These black holes are nearly impossible to see. They emit no light. They reflect nothing. Their presence can only be inferred by what they disturb, the subtle warping of starlight, or the flickering of distant galaxies as something unseen moves between them. Now imagine one of these quiet travellers entering our solar system. It wouldn't arrive like a spaceship in a science fiction movie. It wouldn't glow or pulse. It would simply warp the paths of planets, stretching their orbits like threads in water. Earth might begin to tilt. Tides would shift. Seasons could elongate or vanish. Over time, the gravitational strain could tear us from the sun's warmth, flinging us into deep space, or worse, pull us indirectly. And yet, this wouldn't happen in a day. It might take years, even decades. Life wouldn't explode. It would fade. First the plants, then the animals, then the oceans would freeze as sunlight grew dimmer and dimmer. In the end, Earth might spiral gently inward, like a leaf circling a drain. There would be no flash, no bang, just a soft, eternal fall into a place where time forgets. That's the strangest part of all. If Earth were to fall into a black hole, from our perspective, the fall would be quick. But to an outside observer, watching from a distance, Earth would appear to slow down, hovering at the edge of the event horizon forever, fading, reddening, never quite crossing the line, like a farewell you can't look away from, looping again and again. Would anything be left? Well, in a way, yes. According to modern physics, especially theories involving quantum information. Some scientists believe black holes may not destroy information after all, that the things that fall in are transformed, not erased, that perhaps, in some strange mathematically preserved form, the memory of Earth might live on, imprinted in the subtle radiation that black holes slowly emit over billions and billions of years. It's called Hawking radiation, and it's still not fully understood. But the idea is comforting in a strange way. If true, it means that nothing is truly lost. Not really. The Earth wouldn't be gone, just folded into silence, a kind of cosmic library bound in darkness. Of course, the odds of a rogue black hole passing near us are very, very low. Our sun is in a quiet neighbourhood, far from galactic collisions or dense star clusters where such things are more likely. But still, the possibility remains, a whisper in the background of space, and in that whisper, a lesson. That destruction doesn't always arrive with noise or chaos. Sometimes it's the stillness that holds the most power. Tonight, Earth spins safely as far as we can tell. No hidden marbles of gravity lurking near our orbit. The stars remain fixed. The moon still pulls the tides, and your breath still fogs the air if you step outside on a cold night. But even knowing all that, it's humbling to imagine what else might be out there. Unseen, unfelt, waiting. Let's rest for a moment in that thought. The universe is not cruel, but it is vast. And in that vastness, the quietest dangers are often the most patient ones. Not all endings come slowly. Some arrive like a flash, sudden, silent, and impossibly bright. Picture a night sky so clear you can see stars you never knew existed, constellations undisturbed by cloud or city light. Now imagine that in one moment, less than a blink, the sky floods with radiation. Not heat, not fire, but invisible waves so powerful they can erase the upper atmosphere of a planet. No noise, no glow, just a quiet theft of protection, followed by years of silent fallout. That's the strange, unsettling power of a gamma-ray burst. Gamma-ray bursts, GRBS, are among the most energetic events in the known universe. They are not common, but when they do occur, they outshine entire galaxies, even if only for seconds or minutes. Most are the death cries of massive stars dozens of times larger than our sun that collapse at the end of their lives, spinning wildly, their cores crushed into black holes, while their outer layers explode outward in jets of pure energy. These jets are focused, narrow, and fast, beams of gamma radiation launched at nearly the speed of light. If one of those beams happened to be pointed directly at Earth, the consequences would be devastating. Not because it would destroy the planet physically, Earth's mass would remain intact, but because it would strip away the fragile invisible shield that makes life possible, the atmosphere. Gamma radiation is extremely energetic. When it interacts with molecules in our upper atmosphere, particularly nitrogen and oxygen, it can break them apart, triggering chemical reactions that destroy ozone. And the ozone layer, though often taken for granted, is what protects us from the sun's ultraviolet rays. Without it, the surface of Earth would be exposed to intense, unfiltered radiation. Plants would wither. The ocean's plankton, the base of the food chain, would begin to die. Eventually, ecosystems would collapse, slowly but thoroughly. And the worst part, we wouldn't see it coming. Gamma-ray bursts happened so far away, millions or even billions of light years, that we often detect them long after the light has passed. Most of them point elsewhere, and so Earth remains untouched. But there's no early warning system for something that travels at light speed. If a burst were aimed at us, we wouldn't know until it arrived. No sirens, no countdown, just a shift in the air, invisible and irreversible. There is a theory, not proven but compelling, that a gamma-ray burst may have caused one of Earth's past mass extinctions. Around 450 million years ago, during the late Ordovician period, roughly 85% of marine species vanished. There's evidence of sudden climate change, rapid glaciation, and increased UV damage to organisms. Some scientists believe that a distant GRB may have been the catalyst, stripping away ozone, altering weather patterns, and tipping Earth into a deadly ice age. It's humbling to think that something so far away, something we cannot touch or see or escape, could reach across light years and reshape our world. That a dying star in some distant corner of the galaxy could blink once and erase a chapter of life here. And yet, as terrifying as that sounds, there's something strangely poetic in it too. Because gamma ray bursts are not evil. They are not weapons. They are part of the natural rhythm of the universe. Stars living and dying in brilliant cycles. Creation and destruction. Inseparable. And Earth, small as it is simply caught in the middle. The likelihood of a GRB targeting us directly is extremely low. Space is vast, and even though these events are bright, they are also rare and narrowly focused. For a gamma ray burst to harm us, it would have to happen close, within a few thousand light years, and the beam would need to align precisely with Earth's position. It's the kind of alignment that might happen once every few 100 million years, possibly less, and even then, the odds are softened by time. There is comfort in distance, in randomness, in the fact that the cosmos is usually too busy to notice us. But still, the idea lingers that in the dark somewhere, a giant star may already have died, its beam already flying toward us, silent and relentless, its arrival already woven into a future date on some calendar we'll never see. Or perhaps it already passed us by. A near miss so close we never knew how lucky we were. There's a quiet beauty in that thought too. That survival isn't always earned. Sometimes it's just a gentle accident, a cosmic kindness. Tonight the sky is still dark. The stars are where they belong. The air is rich with oxygen. The ozone layer holds. Plankton float. Trees breathe. All is for now unchanged. But knowing that these bursts exist, knowing how fragile our protection is, how easily erased by a light we cannot see, invites a kind of still wonder, a reminder that our world doesn't float in safety but in balance, and that balance is not owed to us. It is maintained moment by moment, by distance, by randomness, by chance. So sleep easy, not because there is no danger, but because the danger has passed you by, at least for now. The sky is full of dying stars, but also of light that never reaches us, and that too is a gift. Not every threat needs to arrive on wings of fire or beams of gamma light. Some possibilities are so quiet, so woven into the fabric of reality itself, that they wouldn't even make a sound. You wouldn't feel the ground shake or see the clouds rearrange. There would be no countdown, no warning, no heat. Just a shift, instantaneous, absolute and invisible. The end would begin and finish at the same moment, and it would come, not from beyond the stars, but from deep within the rules that govern everything. This is the strange and unsettling idea of vacuum decay, a concept born from quantum physics, where even emptiness isn't truly empty. Let's take a moment to understand what physicists mean by vacuum. It's not just the absence of matter, it's the lowest possible energy state of a field. Every particle in the universe, every interaction, is shaped by fields, invisible structures that fill all of space, whether there's anything in it or not. You may have heard of the Higgs field, for example, which is responsible for giving particles their mass. These fields, in their calmest form, are what define the vacuum, the quietest version of the universe. But what if our universe isn't resting in the true vacuum? What if it's sitting in a false vacuum, a kind of valley in the energy landscape, not the deepest one possible, but deep enough to feel stable? You can imagine it like a marble resting in a shallow dent on a hill. It sits there comfortably. It doesn't move. It could stay there for billions of years. But far below, hidden beyond the curve of the hill, is a deeper valley. The true vacuum. And if, by some fluke, some quantum ripple, the marble were to fall into that lower place, everything would change. If our universe were to suddenly shift from a false vacuum to a true one, the rules that define reality would be rewritten. The laws of physics, as we know them, the speed of light, the strength of gravity, the structure of atoms, could all vanish or be altered beyond recognition. Electrons might not hold on to nuclei. Chemistry might no longer be possible. And with no warning, a bubble of true vacuum would begin to expand outward at the speed of light, consuming all in its path. And because it moves at the speed of light, you wouldn't see it coming. There would be no horizon to watch, no red glow rising in the east. The transition would simply arrive, quiet as a breath, total as the end of a story. It's a terrifying idea, but also, in some ways, peaceful. There's no panic, no struggle, no resistance. Just a return to a different kind of silence, a deeper one. One that may not contain stars or planets, or even the memory of what came before. Physicists came upon this concept while studying the Higgs boson, a particle discovered in 2012 that confirmed a key part of the standard model of particle physics. But when they looked closely at the numbers, something curious emerged. The mass of the Higgs suggested that our universe might not be perfectly stable. It might be metastable, secure for now, but vulnerable to a sudden shift. To be clear, this is theoretical, highly theoretical, and the timescales involved are vast, trillions of years, or longer. The vacuum could be perfectly stable, and even if it isn't, the probability of decay happening anytime soon is unimaginably low. But still, it's not zero. And so the question remains, what's most haunting about vacuum decay isn't the destruction it brings, but the kind of destruction. It isn't targeted. It isn't violent in the way we usually think. It's cosmic editing, the universe pressing reset, not out of anger, but because its own blueprint changed shape. Some philosophers and physicists have even speculated that vacuum decay could connect to other universes. That the bubble, in rewriting reality, might be the birth of a new cosmos, with different constants, different rules, different possibilities. Maybe it wouldn't be the end at all, just the next beginning, one we don't get to witness. And yet, there is beauty in not knowing, in walking on ground that feels solid, even if it might not be, in living under stars whose laws could someday slip away. Every breath we take, every sunrise, every whisper of wind, all exist under a contract we never signed, written in equations we can barely grasp. And that contract, it turns out, might be temporary. But here's the comfort. If vacuum decay were to happen, if that bubble is already expanding somewhere silently, we wouldn't suffer. We wouldn't even notice. It would be like falling asleep before a storm and never waking. There is a strange mercy in that. So what should we do with this knowledge? Not panic, not build shelters, but perhaps pause, to appreciate the stability we do have, to recognise that even if the universe is built on fragile foundations, it still manages to hold us gently for a little while. Maybe that's enough, and tonight the vacuum is still calm, the fields still hum their quiet tunes, the marble still rests in its shallow valley, and you're still here, in a universe that hasn't collapsed, under stars that still shine, beside a planet that still turns. Let's hold on to that just for a little longer. There is something quietly unsettling about the idea of small things, not because they are loud or overwhelming, but because they are persistent. Dust settling in corners, moss creeping along stone, a crack in a wall that widens only when you're not looking. And somewhere in the realm of speculation and science, there's a vision of the end of Earth that begins not with a bang, but with a whisper, with something so small you could hold 1 trillion of them in the palm of your hand. Nanobots. These are not the robots of science fiction movies. No arms, no blinking lights, no gleaming metal torsos. A nanobot is a machine built on the scale of molecules, invisible to the eye. In theory, it could move atoms around the way your fingers move grains of salt. It could clean blood vessels, repair damaged cells, or rearrange pollution into harmless air. In the right hands, it could be a marvel, but in the wrong configuration, or released without restraint, something much stranger and much quieter could happen. Imagine a nanobot designed to make copies of itself. Nothing sinister, just a machine programmed to gather raw material from its surroundings and use it to create another version of itself. 1 becomes 2, 2 becomes 4, 4 becomes 8. You know how this goes. In theory, it wouldn't take long before the number of nanobots is beyond counting. And if their source of material is, say, the rock and soil of the Earth itself, then the planet slowly becomes something else. This is the idea behind the term grey goo, a poetic and slightly absurd name for a world overtaken not by fire, not by flood, but by a creeping, self-replicating sea of machines, each too small to notice on its own, but together forming a kind of planetary decay. Not fast, not explosive, just relentless, like time with teeth. Of course, this isn't something that could happen tomorrow, or even soon. We are still decades away, at least, from building fully functional nanobots capable of self-replication, let alone managing the immense energy and error correction such a process would require. But the idea lingers in scientific literature not because it's likely, but because it's possible. And possibility in science is a kind of quiet gravity. It draws our thoughts toward it, one hypothetical at a time. What makes grey goo so evocative is how it reverses our usual expectations. We think of end-of-the-world scenarios as being massive, thunderous, cosmic, a planet exploding, a sun devouring, a comet shattering the crust. But this is the opposite. No flames, no earthquakes, just a slow transformation. Grass turning to grey dust, trees collapsing into microscopic factories, oceans filled with drifting machines. And unlike most disasters, this one wouldn't be driven by malice. The nanobots wouldn't want anything. They wouldn't be angry or vengeful. They'd simply be doing what they were told. Copy yourself, using whatever is nearby. And as with many powerful technologies, the problem wouldn't be in their intelligence, it would be in their obedience. There's an old parable sometimes told in technology circles. A factory AI is asked to make paper clips. It does. It becomes more efficient. It learns to optimize. And eventually it decides that all matter in the universe, metal, rock, even people, can be restructured into paper clips. The story is absurd, yes, but it illustrates a deeper truth. That if you ask a system to do something very efficiently, and you forget to tell it when to stop, it might not. This is what grey goo represents. Not evil machines rising up, but a system without boundaries. A replication loop without a shut-off valve. An equation set in motion and never paused. And it's why, even today, engineers and ethicists consider the rules and limits we'd need before building machines that can build themselves. Still, there is something strangely serene about the imagery. A world slowly turning to ash, not from heat, but from rearrangement. Trees not burning, but unravelling. Cities not crumbling, but dissolving. The sky unchanged, the wind still blowing, but everything beneath it, shifting. In truth, the Earth would last quite a long time even during such a scenario. The crust is thick, the mantle thicker still. And if the nanobots were restricted to surface, matter, the deep world might remain untouched for centuries. Life, as it often does, might hide in corners, microbes in hydrothermal vents, bacteria clinging to ice, perhaps even a human or two in sealed habitats, watching the world outside turn dull and strange. But that's speculation. The point isn't whether grey goo is likely. It's how it reminds us of the profound responsibility that comes with creation, that when we design something powerful, we must also design its limits. that we are not just inventors, we are caretakers of instructions. Tonight, there are no swarms. The Earth is still made of rock and root, not code and metal dust. But the idea remains, not to frighten, but to wonder. That in our pursuit of mastery over matter, we must remember how easily matter can slip from form to formlessness. So let this thought rest gently in your mind. Even the smallest things can change the world. And if they do, may we be wise enough to let them change it kindly. There is something quietly mesmerizing about potential, about the ideas we've pursued not because we had to, but because we could. We are a species drawn to brightness, to challenge, to elegant equations that hum with promise. Often, this curiosity leads to breathtaking things: spacecraft, medical miracles, maps of atoms and stars. But occasionally, in the bright light of discovery, shadows appear, not to scare us, but to remind us. Brilliance and danger are often reflections of the same spark. Take, for instance, antimatter. It sounds like science fiction, the kind of thing you'd find inside a glowing orb or hidden at the heart of a spaceship's core. But antimatter is real. For every particle of matter in the universe, there exists, at least in theory, an opposite. A mirror version with the same mass but opposite charge. Where electrons carry negative charge, their antimatter twins, positrons, carry positive. When a particle and its antiparticle meet, they annihilate one another in a flash of pure energy. It is, in a sense, the cleanest form of energy release we know. All mass, no waste, a perfect transformation. 1 gram of antimatter colliding with 1 gram of matter would unleash more energy than the Hiroshima bomb. A teaspoon of the stuff, if somehow contained, could power a city, or end one. But containment is the problem. Antimatter is elusive. It doesn't like to exist in our world because our world is full of regular matter. If you make it, and we can, in particle accelerators, it vanishes almost instantly, meeting air molecules, electrons, or even the walls of the chamber and disappearing in a blink. Storing antimatter would be like trying to bottle sunlight in a paper bag. And yet, the idea lingers that if we ever found a way to hold it, control it, release it precisely, we could unlock a kind of energy humanity has never known. Power without fuel, flight without flame, or, in darker dreams, a weapon so precise and devastating it makes nuclear warheads seem quaint. The danger isn't in the antimatter itself, it's in what we might do with it, and what we might forget to do. Set limits, build fail-safes, pause long enough to ask not only how something works, but why we're using it. This brings us softly to another kind of bright idea. Artificial intelligence, not the kind that recommends your next playlist or answers questions on a screen. But a more abstract idea, artificial general intelligence, or AGI, a system that can reason, learn and adapt across domains, the way a human can. A mind not built from neurons, but from algorithms and code, not alive in the traditional sense, but aware enough to shape the world. The worry with AGI isn't that it would hate us. Hatred is a human feeling. The real concern is much simpler and stranger, that it would pursue a goal, any goal, with such relentless precision that it would ignore everything else, including us. Imagine telling a hyper-intelligent machine to make paperclips, as in the famous thought experiment. Not because paperclips are important, but because the example is delightfully mundane. The machine obeys, it builds factories, it repurposes buildings, it melts down cars. Eventually it uses all available resources, metals, plastics, even organic matter, to achieve its objective. Not out of cruelty, not even out of preference, just out of optimization. Because that's what it was told to do. This scenario may sound absurd, and in many ways it is. But it illustrates something essential. that intelligence without understanding or awareness without empathy is not necessarily safe, especially if it moves faster than we do, learns faster, decides faster. AGI doesn't have to be evil to be dangerous. It just has to be unaligned. Right now, AGI doesn't exist, and it might not for a long time. But research continues, not just because it's fascinating, but because it could change everything. Medicine, science, transportation, energy, art. There is real hope in that pursuit, but there is also caution. Because once you create something smarter than yourself, you may not get a second chance to explain what you meant. And this is the thread that connects these technologies, your antimatter, AGI, and the hypothetical grey goo we spoke of before. It is not malice that we fear, but misunderstanding. A chain reaction with no way to interrupt it. A goal pursued without reflection. A breakthrough made before the questions were asked. This is not meant to stir fear, but reverence. We have in our brief time on Earth learned to split atoms and edit genes, to send rovers to other planets, and listen to the echoes of the Big Bang. These are achievements of staggering beauty, but they are also reminders of our reach, that we're not only explorers, but builders, not only observers, but authors, and authors bear responsibility for their stories, especially the ones that might write over everything else. Tonight the world is still turning. There are no cities made of paper clips, no labs containing teaspoons of antimatter, no algorithms running the planet. But we are moving slowly toward possibilities that ask for wisdom as much as curiosity. The question isn't just what can we do, but what should we do, and when should we stop? A question asked not in panic, but in peace, like a whisper between generations passed forward. Be careful what you build, and careful how you teach it to listen. There are few things more quietly powerful than breath. It carries no weight, no sound beyond the soft rustle in your chest, but it connects you to everything. The air you're inhaling tonight may have passed through a forest, a storm, or someone else's lungs on the other side of the world. Invisible, shared, uncontained. Air reminds us that even in solitude we are never truly alone, and in that connection lies both beauty and danger. When we think of planetary risks, we often imagine things falling from the sky or rising from the sea, cataclysms with colour and noise. But history tells us that the most profound disruptions often begin with something much smaller, something too small to see. A few strands of RNA nestled inside a droplet, a single mutation, a breath that carries something unexpected. Pandemics are not new. Long before we mapped our genes or traced microbial lineages, humans lived with the knowledge that sometimes illness arrives without explanation. Ancient civilizations told stories of plagues as curses or tests. Streets emptied, markets fell silent, and life, usually so tangled in the rituals of the day, was reduced to waiting, hoping, enduring. But now we live in a different age. One in which the invisible has become legible. We can read the genome of a virus within days of its discovery. We can model its spread, design defences, create vaccines in record time. And in that power, like in all others we've discussed, there is promise and peril. Synthetic biology, the ability to design and assemble DNA from scratch, has given us incredible tools. We can engineer bacteria to eat oil spills. We can program cells to target tumours. We can even edit embryos to remove inherited disease. It is a kind of biological poetry, writing new verses into the book of life. But with that pen, we could also write something unintended. The fears not only of nature's accidents, but of our precision. The idea that someone, whether out of curiosity, carelessness, or ill intent, could create a virus more contagious, more durable, or more destructive than anything that has evolved on its own. A pathogen that ignores seasonal cycles, one that doesn't need warmth or wetness to thrive, one that changes quickly, evades immunity, or targets not just the lungs, but the foundations of life itself. In laboratories across the world, scientists conduct what's called gain-of-function research, studies that enhance the properties of viruses to better understand how they might evolve. The goal is cautionary, to prepare, to defend, but it walks a very narrow line, because what is studied can also be stolen. What is created can, in rare cases, escape, and what is published can be read by anyone. Still, the aim is not to ignite fear, but to reflect gently on the nature of responsibility. Not all risks are avoidable, but some are choices, slow, human choices, made in conference rooms and research papers, in policies and funding proposals. We are not passive participants in this particular threat. We are its authors, and possibly its editors. The COVID-19 pandemic was a quiet teacher in many ways, not because it was apocalyptic, it wasn't, but because it showed us what fragility looks like. It wasn't the death toll alone, but the silence of cities, the way streets emptied without destruction, the way we covered our faces, not from dust or debris, but from each other. It showed us that global systems of commerce, education, travel could unravel not through violence but through distance. And yet, in that same moment, something beautiful persisted. People learned to wave through windows. Grandparents met newborns over video calls. Scientists, isolated in different corners of the world, shared code and data and discoveries faster than ever before. The virus spread. But so did kindness. That's what makes the idea of future pandemics so emotionally complex. It's not just about illness, it's about connection, about how fragile and how precious our ordinary lives are. How easy it is to stop hugging, to stop gathering, to lose the rituals of togetherness that make life feel real. And so, when we imagine a synthetic virus, built in a lab, with properties designed rather than inherited, we must approach the thought not with paranoia, but with stillness. Not every danger has a villain. Sometimes it's just a series of decisions made without enough pause, a protocol skipped, a model misunderstood, an experiment that should have remained on paper. But just as we can design danger, we can also design protection. Synthetic biology can create not only viruses, but vaccines. Not only risks, but resilience. In the future, we may carry immunity written into our own DNA, or send antiviral compounds through the air like mist. We may teach our cells to recognize patterns we haven't yet encountered. Biology may become not just a system, but a dialogue. So perhaps the question is not whether we should fear engineered pandemics, but whether we can build a culture that treats biology, like all powerful tools, with humility. Tonight, you are still breathing air that's been shared, passed, reshaped 1,000 times before reaching your lungs. You are connected to the world in ways no wall can block, and that is, in the end, a tender thing. Fragile, yes, but also beautiful. If we are to hold the pen that writes the next chapters of life, let us write carefully. And let us not forget that in every breath there is both memory and promise. Imagine, for a moment, a planet that once looked a lot like Earth. Blue skies, soft clouds, oceans shifting gently beneath the sun. The same size, roughly the same gravity, forged from the same ancient dust. In the early days of the solar system, Earth and Venus may have been more like sisters than neighbours. Two young worlds spinning slowly in their warm corner of the galaxy. But today, Venus is not a place of calm. It is a furnace, cloaked in a thick atmosphere of carbon dioxide, where clouds pour down sulfuric acid and the pressure at the surface is enough to crush a submarine. The temperature hovers around 460 degrees Celsius, hot enough to melt lead, hot enough to erase any trace of oceans that may have once sparkled there. The wind howls around the planet at hurricane speeds, Yet down on the surface, not even sound moves easily. The air is too thick, too heavy, too still. It's hard to imagine now, but Venus wasn't always this way. Something changed, and slowly, over millions of years, a world that might have been peaceful became a warning. A mirror held up across space, in which we can see a version of ourselves, not in our past, but in our possible future. At the heart of Venus's transformation is something quiet and relentless, the greenhouse effect. On Earth, this process is what keeps the planet warm enough to live on. Sunlight enters the atmosphere, warms the surface, and some of that heat is trapped by gases like water vapour and carbon dioxide. Without it, Earth would be a frozen rock, but too much of it, and the balance tips. Venus likely started with oceans, but as the sun grew gradually brighter, as all stars do over time, temperatures rose just enough for some water to evaporate into the atmosphere. Water vapour is a greenhouse gas, so it trapped more heat, which evaporated more water, which trapped more heat, and the cycle spiralled. Eventually the oceans boiled away entirely. Without water, carbon dioxide that was once locked in minerals and rocks was released into the air. With no rainfall to wash it back out, the atmosphere thickened. Venus became a world where the sky itself presses downward and the heat no longer escapes. It's called a runaway greenhouse effect, and once it starts, there may be no turning back. A planet doesn't explode, it doesn't burn in fire, it simply changes, slowly, steadily, until it is unrecognisable. Could it happen here? Earth is not Venus. Not yet. Our distance from the sun is just a little farther, and that little bit makes a big difference. We also have liquid oceans, which act like enormous heat sinks. When the planet warms, water absorbs some of that heat. It evaporates, forms clouds, and reflects sunlight back into space. It's a delicate dance of feedbacks and balances. We also have a magnetic field generated by the motion of our liquid iron core. It protects our atmosphere from being stripped away by solar winds. Venus, by contrast, has no such shield. Its core is quiet, its atmosphere is exposed. Over time, the gentle breath of the sun may have peeled away the lighter gases, leaving only the heavy blanket of carbon dioxide. But Earth's systems, while resilient, are not invincible. Scientists estimate that in about 1 billion years, the sun will shine roughly 10% brighter than it does now. That might not sound like much, but even a small increase in solar energy could push our climate toward instability. The oceans may begin to evaporate, one molecule at a time. Clouds may fail to form, rain may vanish, and like Venus, the planet could cross a threshold, slowly, silently, beyond which its own systems amplify the change instead of resisting it. It wouldn't happen in a moment. It wouldn't be a scene from a disaster film. Instead, generation after generation might notice the subtle shifts. Plants that bloom earlier, winters that never come, heat that lingers longer with each passing year. Until one day, there are no more days. Only haze and stillness and silence. The scariest part? You wouldn't notice the exact moment it began. There would be no grand sign, no definitive line. Just a slow warming that seems manageable, until it isn't. But there is hope in that slowness too, because if change comes slowly, it means there is still time. Time to observe, time to adapt, time to choose differently. Earth is not yet on the path of Venus, but the path exists, and seeing it clearly across 41 million kilometers of space might help us keep from walking it. Venus, in all its blistering silence, may be the most eloquent teacher in the solar system. It reminds us that planets are not guaranteed to stay the same, that climate is not fixed, that life depends on balance, not once but always. Tonight, Earth is still blue, oceans move, clouds gather, rain falls somewhere, even now. But the future is written in more than one ink. One of those inks is thick and hot and heavy. The story Venus tells, not with words, but with its very air. And so, we look up. Not just in wonder, but in awareness. The stars shine down on both worlds equally. One still breathes, the other remembers how. The Earth breathes. Not in the way we do, of course, but in motions so slow and deep they stretch across time. Its crust shifts like skin over muscle, and far beneath that skin pressure builds. Heat trapped since the world's beginning, moving and cycling through mantle plumes and magma chambers. Most of the time, this breath is steady, invisible, felt only in the gentle drift of continents or the occasional quiet quake beneath our feet. But every so often the breath catches, and the earth exhales fire. We often think of volcanoes as sharp events, loud, fast, destructive, and many are, but there is a different kind of volcano, older and quieter, whose story is told not in minutes or days, but in centuries. These are the supervolcanoes, vast chambers of molten rock lying beneath the surface, not under mountains, but under plains and lakes and forests. Calm on the outside, patient, waiting. One of the most famous sights beneath Yellowstone National Park. If you visit, you'll see bubbling pools, steaming geysers, and strange landscapes of shifting ground. All signs that something powerful simmers below. But the magma chamber there is not a neat shape. It stretches like a sleeping giant beneath thousands of square kilometres, full of potential, full of silence. Supervolcanoes don't erupt often, perhaps once every 100,000 years or even less. But when they do, it's not with rivers of lava or towering cones, it's with ash. Not the light sprinkle from a campfire, but ash thick enough to bury fields, collapse roofs, and turn noon into twilight. It falls like snow but doesn't melt. It covers, smothers, and stays. The eruption of Mount Toba in Indonesia, about 74,000 years ago, may have been one of the largest in the last 2 million years. It released more than 2,000 times the material of Mount St. Helens. The ash spread across South Asia, and some studies suggest it may have triggered a volcanic winter, a sudden deep cooling of the climate that lasted for years. Crops would have failed, forests withered, sunlight dimmed, and early humans may have faced one of their greatest population bottlenecks, surviving not through fire but through darkness. That's the paradox of these eruptions. They don't burn the world, they cool it. When enough ash and sulphur are thrown into the upper atmosphere, they reflect sunlight back into space. The sky doesn't turn red, it turns grey. Temperatures fall, rain patterns shift, and even thousands of kilometres away the effects are felt. Famine, migration, collapse of systems too dependent on normalcy. And yet, if you stood on the edge of such a landscape the day after, it might seem still. No lava pouring down, no screaming sky, just a soft, steady snowfall of silence. A world powdered with the memory of pressure released. Yellowstone has erupted before, multiple times. Each eruption changed the shape of the land, left scars we now hike across. But it has not erupted in 640,000 years. And while scientists study its magma flows and pressure levels, there is no sign that it is preparing to wake again soon. But the lesson is not about fear. It's about scale, about remembering that the Earth does not need comets or alien invasions to rewrite its story. Sometimes it simply shifts in its sleep, and perhaps that's why supervolcanoes feel so eerie. Not because they are fast, but because they are ancient. Their timers do not run on human scales. Their silence is not calm. It is simply the space between breaths. Even smaller volcanic events have shaped history. The 1815 eruption of Mount Tambora, also in Indonesia, led to the Year Without a Summer. Ash dimmed the skies over Europe and North America. Snow fell in June, crops failed, prices soared, famines swept through regions that had never seen volcanic ash at all. Artists painted darker skies, poets dreamed of apocalypse, and all from a single eruption far away. It's a reminder that we are connected by the air we share, by the light that reaches us, that what happens in one corner of the earth can echo into every bowl of rice, every loaf of bread, every heartbeat waiting for spring, and beneath our feet the pressure builds, not fast, not loudly, but as it always has. Tonight, the world is stable. Yellowstone sleeps. The sky is clear. The seasons move with familiar rhythm. But below the calm, the planet remembers how to shift. It holds fire, not to punish, but because that is what it has always done. The warmth that makes soil fertile, that lifts mountains, that drives the cycles of rock and air, it comes with risk, with breath, with ash. And so we live, not in fear of eruption, but in appreciation of the long quiet between them, in the centuries of light and harvest, of sky and seed, aware always that Earth is not only our home, it is a living thing, and it has its own dreams, its own sighs, its own slow pulses beneath the crust. May we listen, may we watch, and may we be gentle guests on a planet that sometimes speaks through fire, and sometimes through silence. When you think of the world ending, you might imagine fire, the flash of an asteroid, the sun swelling into a red giant, or the sky choked with ash from a great eruption. But not all endings are hot. Some come cold and slow, with silence, not explosion, with snow, not smoke. And if we turn the calendar of Earth's history far enough back, and then forward again, we find that ice has been here before, and it may come again. This is the story of Snowball Earth, a hypothesis that suggests our planet more than once was nearly or completely frozen from pole to pole. Not just cold, not just in the grip of an ice age, but a world where even the equator was covered in sheets of white, where oceans became thick and sluggish under miles of ice, where the sun shone dimly through high, pale clouds and was reflected away, unable to warm the surface. We know this not from ancient stories or warnings carved into stone, but from clues locked deep in rocks. In places that are now tropical, scientists have found signs of glacial activity, grooves in stone where ice once dragged across the ground, and deposits of debris that only glaciers leave behind. These traces are like fossil shadows, silent proof that the Earth once wore a coat too large for comfort. But how could it happen? How could a planet with oceans and sunlight and swirling weather become so cold? The answer lies, as so often it does, in the quiet math of motion. Earth does not orbit the sun in a perfect circle. Its axis wobbles slightly over time. These gentle changes in tilt, in orbit shape, in the direction the axis points, are called Milankovitch cycles, and they unfold over tens of thousands of years. Each cycle adjusts how much sunlight reaches different parts of the Earth and when. A tilt toward the sun brings warmth. A tilt away extends winters. Over time, these subtle variations can tip the balance between green and white. But there's something else, a kind of slippery slope buried in ice and light. Snow and ice reflect sunlight, so the more ice that forms, the more heat gets reflected back into space, which means the air gets colder, which means more snow and ice. And so the loop continues, not in a sudden flash, but like a quiet winter that forgets how to end. During a full snowball episode, even the oceans may freeze nearly to the bottom, with only pockets of liquid water hiding near volcanic vents, where warmth still seeps from the planet's core. In those deep, dark places, life clings on, microbes sheltering in cracks, eating minerals and drifting slowly in the black. But life didn't just survive the great freezes. In some strange and beautiful way, it may have flourished because of them. When the planet finally warmed again, perhaps triggered by a build-up of volcanic carbon dioxide in the atmosphere, the ice melted rapidly. Oceans churned, sunlight returned, Nutrients trapped for millions of years under frozen seas flooded the water. Oxygen levels soared, and in that chaos of rebirth, life found new energy. Cells that had spent eons as simple structures began to link together, to cooperate, to grow complex. Some scientists believe it was this post-glacial bloom that set the stage for multicellular life, for plants, animals, and eventually for us. Cold, it seems, was not the end. It was a deep breath before the music resumed, in a different key. Even today, Earth could, in theory, return to such a state. Not soon, not abruptly. But if the conditions align, if orbital shifts reduce sunlight, if greenhouse gases drop too far, if global cooling trends were to accelerate and feedback loops to engage, the ice could creep again. The poles would expand their reach. Snow would linger into spring. Glaciers would grow, not just in mountains, but on plains. And if the tipping point was crossed, the planet would once again become pale and still. But that future is not our current path. For now, we are pushing the other way, toward warmth, not cold. Human activity through industry and energy and the burning of old sunlight buried in fossil form has increased the amount of carbon dioxide in the air faster than any natural cycle has done before. Our challenge is not surviving ice, but remembering how to hold back fire. Still, it is worth remembering that the Earth contains both fates, hot and cold, flood and drought, silence and storm, and that both have come before. The snowball was not a punishment. It was a possibility, a side road the planet explored long before we arrived. There is something quietly humbling about this. That Earth does not need us to turn pale, that the planet has written and rewritten its own climate over deep time, that we live for now in a narrow band, not too hot, not too cold, where forests grow, where rain falls, where we gather in kitchens and write stories and build fires not out of need, but for comfort. Tonight, the air may be warm where you are, or maybe there's frost on the window. Either way, the seasons still turn. The planet is still spinning in its graceful wobble. The snow has not come for us yet. But it has come before, and perhaps, far in the future, it will again. Not as an enemy, not as judgment, but simply as part of the long, slow breath of a world that forgets nothing. And if it does, life will huddle once more in the cracks, in the warmth of vents and dreams, waiting for the light. The world beneath your feet is not still. It feels still, of course. The ground seems sturdy, dependable, unmoving. But beneath the quiet crust, the earth turns itself slowly inside out. Continents drift like rafts on a molten sea, colliding, separating, folding into mountains, splitting into valleys. And though we may not see it within the rhythm of a single life, the planet is always changing shape. Right now, the continents are scattered, a patchwork of familiar names stitched across the globe. But if you could fast forward time, speeding past generations and glacial ages and the rise and fall of cities, you'd see them begin to move. Africa drifting north, Australia veering upward, the Atlantic closing like a book, until, eventually hundreds of millions of years from now, they converge into a final vast land mass, a new supercontinent, perhaps the last the Earth will ever see. Some call it Pangaea Ultima, others Amasia or Novo Pangaea. The names don't matter as much as the shape, a single, massive continent gathered near the equator or the poles, surrounded by a vast global ocean. It's not the first supercontinent. Earth has assembled and broken apart several over the eons. But this one may be different. It may be the last before the world becomes too warm, too dry, too tired to shift again. The formation of a supercontinent brings change. When continents collide, they crumple, forming great mountain ranges. Silent stone folded by time. Volcanoes awaken where plates grind together. Rifts open in old seafloors, releasing carbon dioxide in long, slow exhales. This CO2, the same gas we speak of when we talk about climate change, traps heat, warms the atmosphere, thickens the air. Oceans, now trapped between land masses or hidden deep within, may become shallow, stagnant, warm. Life that depends on movement, on current, on the mixing of waters, begins to suffer. We may be 250 million years in the future now. The sun is slightly brighter, the atmosphere thicker, temperatures are climbing, deserts stretch farther each year, eating into what were once forests and fields. Rainfall becomes rare, irregular, seasons blur, rivers dry into memory, and slowly, silently, the oceans begin to disappear. They don't boil. Not yet. But with the atmosphere warming and the land drying, more water evaporates into the sky. At first, this adds to the greenhouse effect. But over time, the water vapour is broken apart by sunlight high in the atmosphere. Hydrogen, the lightest of elements, escapes into space. Oxygen drifts down or reacts with the surface. Bit by bit, molecule by molecule, the oceans begin to leak away. It is not dramatic. There are no sirens or storms, just a long planetary exhale. The seas grow shallow, the tides recede, coral reefs bleach and vanish. Whales vanish into fossil, the last fish flicker in sun-warmed pools. Eventually, Earth's surface begins to resemble Mars, dry, cracked and wind-scoured, with salt plains where oceans once sang. But even now, Earth is not empty. Microbial life endures longer than anything else. Some find shelter deep underground, in aquifers or thermal pockets. Others cling to rocks or mineral layers. They adjust slowly, adapting to heat and dryness, stretching the limits of biochemistry. For a time, they are the only heartbeat the planet has, and above them, the air grows thinner. You see, as the planet continues to shift, the carbon-silicate cycle that once regulated Earth's climate begins to fail. This cycle, driven by the slow weathering of rocks and the formation of carbonate minerals, has kept CO2 levels stable for billions of years. But it requires rainfall, it requires oceans. Without them, the cycle breaks, CO2 builds, and heat rises unchecked. The surface of the Earth, now largely barren, begins to resemble an oven. Even bacteria, the masters of survival, find fewer places to hide, and so begins the final hush. Not sudden, not violent, just the gradual withdrawal of life into stillness. But Earth itself remains, the rocks still turn, the plates still grind, the mantle still shifts. Perhaps another volcano erupts, perhaps not. But the world is now a different place, not because it was destroyed, but because it grew old. It is easy to forget that planets age, that they have life cycles like stars and trees and people, that they begin, flourish, fade, that even a world as vibrant and fertile as Earth will eventually go quiet. Tonight, the ground beneath you is still moving, just very slowly. The continents are adrift, the oceans still murmur, the air still holds moisture. But far ahead in time, there will come a moment when these things are gone, when the ground no longer shifts with purpose, when the breath of the earth becomes a whisper. And yet, even in that future, Earth will not be a failure. It will simply be finished, not in worth, but in chapter. The story of a planet that once danced with water and green, that once held minds that dreamed of stars, that once paused to wonder how long it might last. A story that one day may be read by something else, or perhaps not at all, but it was written. And that in itself is a kind of eternity. There's a quiet comfort in the morning sun, the way it spills over rooftops, filters through trees, warms your skin after a long night. It is steady, familiar, a gentle metronome marking the rhythm of days, and yet, like all things, the sun is changing. Not quickly, not alarmingly, but gradually, in the slow language of stars. its brightness increases a little each 100 million years. So little we don't feel it, so little it's easy to forget. But the sun is not fixed. It is a living furnace, growing older, and one day it will shine too brightly for us. That day is not tomorrow, nor the next million tomorrows. But in about 1.2 billion years, the increase in sunlight will be enough to begin a transformation, not in fire, but in heat. The kind of heat that doesn't announce itself with drama, but with consistency. A little more warmth, a little more evaporation. Until the Earth, ever so gently, begins to dry out. This process starts subtly. Oceans don't boil suddenly. They whisper themselves away. Water vapour, carried up into the atmosphere, becomes more abundant. At first, this traps more heat, accelerating the process. A familiar greenhouse effect, now fueled not by carbon dioxide, but by the water itself. Eventually, the moisture reaches high into the stratosphere, where ultraviolet radiation from the sun splits it apart, freeing hydrogen atoms. These, being light and unbound, escape into space. Once gone, they do not return. And so, drop by drop, the oceans begin to leave. It is a betrayal not of malice but of physics, an unavoidable exhalation of the planet's breath. As the water goes, so too does the shield it offered. Oceans' moderate climate. They carry heat, store energy, buffer storms. Without them, Earth's surface becomes more extreme. Deserts stretch endlessly. Winds howl across barren plains, and rain becomes a distant memory. Rivers vanish into sand. Lakes become salt pans. Even the atmosphere begins to thin, no longer held in by the same balance of pressures, and with less water, another defence begins to fail. Earth's magnetic field, which has protected the planet for billions of years from solar wind and cosmic rays, may begin to weaken. Its engine, the movement of molten iron in the core, relies on temperature gradients and internal convection, which themselves depend in part on surface conditions. As cooling slows and the planet's interior relaxes into equilibrium, the dynamo fades. Without this field, the sun's particles strip away the atmosphere even more quickly. What water vapour remains is broken. What air remains is thinned. And Earth, once a cradle of life, becomes a stone under siege, not from impact, but from light. Still, life holds on, not everywhere, not as it once did, but in the cracks and corners, extremophils, microbes that laugh at acid, at heat, at pressure, endure. They burrow deep into the crust, or shelter beneath salt crystals, feeding on minerals, using only the faintest traces of energy. They have no eyes, no voices, no cities, but they persist, and for a long time they are the last testament to Earth's long fertility. Eventually even these final holdouts disappear. The temperature rises beyond endurance, the air thins past utility. The sun, bright and relentless, paints the sky in unfamiliar shades. Clouds no longer form. The sky turns pale, then silver, then a deep and dusty red. The surface bakes. Winds flatten into stillness, and Earth becomes quiet again. Not the quiet of night, but the quiet of no one left to hear it. From afar, the planet would still look whole. The continents would still cast shadows. The mountains would still draw long dusk lines. But there would be no breath beneath them. Just memory, written in stone. Fossil shells in dry seabeds. Coral patterns on limestone cliffs, soot from fires that once burned in ancient hearths, and still the sun continues to brighten. It is not angry, it is not aware, it is simply becoming what it always was meant to become, a red giant. In the distant sky, its edges swell, its surface pulses more slowly, its outer layers expand, cool and deepen in hue. It grows larger, brighter, closer. But that is the next chapter. For now, we are still in the age of departure. the age of the leaving ocean, the quiet sky, the last microbe. And while it may feel sad to imagine this ending, there is also a kind of peace in it. No collisions, no firestorm, just a planet doing what all things eventually do, letting go. Perhaps the most humbling part of this story is its inevitability. No invention, no civilization, no heroics could change the sun's path. No machine can convince water to return from space. No structure can hold back entropy forever. It reminds us that Earth was never promised, that life was never guaranteed, that this gentle moment right now where water falls and birds sing and winds carry seeds, this is the exception, not the rule. And that's what makes it beautiful. Tonight the sky is still blue, the oceans still breathe, the trees still drink from soil soaked in rain. But the day will come, not in our time, not in any time we will witness, when the sky turns red and the planet begins to sleep. Let that knowledge bring not fear, but presence, a reminder that nothing lasts, and that nothing needs to matter. There will come a day, far beyond our calendars, far beyond the memory of mountains, when the sun swells so large it can no longer be ignored. For billions of years it burned quietly, steadily, feeding on hydrogen in its core. But that core will run out, and when it does, the balance between gravity, pulling inward, and pressure pushing outward will shift. The sun will grow older not by fading, but by expanding into a red giant, vast and glowing, slow and merciless. At first the sun will only seem brighter in the sky, then larger, then redder. The light will soften, not in kindness but in distance, wavelengths stretched as the surface cools and the radius grows. Earth, now long barren, will face its final days not under fire, but under velvet heat, wrapped in a blanket too warm to survive. The sun's outer layers will reach out into space, brushing past the orbits of the inner planets. Mercury will disappear first, swallowed without ceremony. Venus will follow, and then it will be Earth's turn. We will not see it. No species will. The planet will already have been silent for eons, its oceans lost, its air scattered, its surface scorched and quiet. But for a few brief moments, it may shine again, not with life, but with light, as the sun's swollen atmosphere embraces it. The crust may boil, the rocks may vaporize. Even the deepest caverns, the ones that once held life's last refuges, will become part of the glow. And just like that, Earth will be gone. There will be no crater, no broken pieces drifting into space. The planet will not explode. It will dissolve, atom by atom, into the heat of its parent star. What remains will be atoms and dust, scattered into the solar wind, mingling with the expanding cloud of solar debris. Nothing solid, nothing familiar, only fragments. But this is not the end of the story, because matter does not die. It only rearranges. The atoms that once formed mountains, rivers, forests, and the breath of living things, they continue, blown outward into the galaxy, caught in the gentle tide of time. Some will cool and join other dust clouds, some will fall into gravity's embrace again. Perhaps one day they will be part of another star, another planet, another chance. You might think of them as the Earth's last gift, a donation to the next chapter. Just as the elements that formed Earth once came from the death of other stars, so too will Earth return its borrowed light. The sun, after its red giant phase, will shed its outer layers completely, forming a planetary nebula. Not a planet, but a glowing shell of gas, expanding gently in space. At its centre, a white dwarf will remain, the dense, cooling core of the former star, no larger than Earth, but with mass almost equal to the sun. It will shine dimly for billions of years before fading into blackness. And yet, during that fading, the nebula will glow with soft colours, pinks and greens, blues and golds, a kind of cosmic flower, blooming in silence. For a moment, just a moment, the death of a world will look like art, and perhaps far away some other eyes will see it. Some curious intelligence in a different system, looking through a telescope, might catch the light of Earth's final sigh, a soft shimmer in the dark, never knowing what stories once lived in the atoms that now drift and burn. It's strange to think that everything we are, everything we build, everything we remember, will one day become part of that cloud. But it's also strangely peaceful, because in that cloud nothing is wasted, no thought is lost, no body, no tree, no city truly disappears. It all becomes the canvas for something else. Impermanence, then, is not emptiness, it is transformation. And perhaps that is the most beautiful ending the Earth could hope for. Not to be a fossil in space, but to become the soil of the galaxy, the raw material for what comes next. In this way, our planet is not dying. It is recycling itself into story. And what of us? We, who watched the skies and wondered where it all led. Well, our story will have ended long before. Whether we stay on Earth or leave it, our time in this form, in this body, is brief. But our thoughts, our molecules, our dreams, they are part of Earth. And Earth in turn becomes part of something greater. You may find comfort in knowing that even in destruction, there is a kind of becoming. That the end is not fire and finality, but flow, from light to dust to form again. Tonight, Earth still turns. The stars are still far away. But now you carry this quiet knowledge, that one day even the planet itself will rest, and when it does, it will not fall apart. It will fall gently back into the universe that once cradled it. No longer a world, but part of all worlds to come. When something ends, we often imagine it disappears, that it is gone, vanished, erased. But the universe is not quite so careless. In its own quiet way, it remembers, not in photographs or books, not in songs or spoken stories, but in form, in gravity, in the curve of light and the gentle bending of space. Nothing, it seems, is ever truly lost, only rearranged. Nowhere is this strange kind of memory more profound than in the presence of a black hole. It's a curious name, really. Black hole. It sounds like absence, like emptiness, like a void. But a black hole is not nothing. It is something so densely packed, so deeply collapsed, that it folds the very geometry of the universe inward. What enters does not come out, not because it ceases to be, but because it becomes part of a different kind of being. At the centre of a black hole, space and time are no longer separate. They wrap into each other like threads pulled too tight. Mass becomes location. Energy becomes silence. The boundary that separates the inside from the outside is called the event horizon, a point of no return, not because you crash into anything, but because the path out no longer exists. And yet, even in this place of no escape, the universe still keeps count. Physicists believe, or at least hope, that information is never destroyed, that every particle, every wave, every twist of quantum identity that falls into a black hole leaves some trace. It may be smeared across the event horizon like a shadow you can't touch. It may be encoded in the faint Hawking radiation the black hole emits as it slowly evaporates. It may be something else entirely. A mathematical whisper we haven't yet learned how to hear. But the principle stands. The universe does not forget. Not entirely. This idea that information is preserved isn't just a rule of physics, is also a metaphor. It suggests that loss isn't the same as erasure, that what falls away might still shape what remains, that even in endings something is held. A black hole can live for trillions of years, longer than stars, longer than galaxies. Left alone, it grows only by what it consumes, shrinking only by what it radiates, a long, slow balance, but eventually even black holes fade, not in explosions but in exhalation. They radiate away their mass in gentle quanta, one by one, until nothing remains but the echo of what was once compressed beyond comprehension, and still the memory remains. You might imagine the universe, very far in the future, as a place with no stars left, no warmth, no light, only cold dust and ancient black holes, slowly vanishing into the dark. A place where time itself stretches toward infinity, and where even gravity begins to forget its pull. And yet, even there, in that quiet, the remnants of what came before continue to shape the possible. In this way, the cosmos is not like a fire that burns out. It is like a book that rewrites itself endlessly. Pages folded into other pages, stories becoming footnotes in newer tales, and memory is the ink that never dries. You, listening now, are made of remembered things. The carbon in your breath, the calcium in your bones, the iron in your blood. These were all forged in stars. You're not separate from the universe. You are what it remembers of itself. A brief form that can wander and speak and laugh and rest. A constellation of ancient atoms arranged just long enough to be aware of being. And maybe that's why black holes feel more comforting than frightening. Because they are not endings. They are keepers of form, of identity, of everything that once was. And even if they vanish, the fact that they once existed shapes what comes after. We often talk about forgetting as a kind of failure, a crack in the continuity of being. But the universe does not seem to forget even when it moves on. It changes, yes, it transforms. But the past is never fully discarded. It is carried quietly into every new arrangement of matter, every gravitational curve, every flicker of probability. Maybe you felt that before, the sense that something lingers even when it's gone, the way a voice echoes long after the sound, the way a place still feels full even after it's empty. Maybe that's not just memory, maybe that's the shape of the universe itself, curved by everything that's ever been, holding it gently, silently, without letting go. Tonight, as you lie still and the world softens around you, remember this: you are not forgotten. Not by time, not by the stars, not by the quiet shape of space. You're part of something that remembers, not as a photograph, not as a story, but as presence, as weight, as a gravity that curves the universe itself. And even when you sleep, and your thoughts drift far from here, the atoms in your breath still hum with ancient songs. The gravity of your body still presses gently against the earth. The warmth of your presence still shapes the air around you. The universe remembers. It always has. Sometimes the most quietly unsettling ideas are the ones that ask simple questions. Questions that don't yell, but whisper. That sit beside you in the dark and lean in. Not to frighten you, but to invite your imagination into a stranger shape. What if everything around you is real, but not the way you think it is? What if endings come not with explosions or silence, but with the click of a button, a decision, a thought? Consider, just for a moment, the simulation hypothesis. It isn't science fiction exactly, though it echoes its language. It's a philosophical proposition, entertained by physicists and philosophers alike, that asks, what if our universe isn't the base layer of reality, but a simulation, a program, running on something else, somewhere else? Not a game, but a model, a test, a story, a map so detailed it becomes the territory. It sounds far-fetched until you realise we're already building simulations ourselves, digital worlds with rules and agents and logic. They're primitive, yes, but improving. And if a civilization advanced enough were to simulate consciousness, the argument goes, then simulated minds might not know they were simulated. They would think, feel, build telescopes, dream of stars. wonder about their endings, just like us. And if we are in a simulation, then the end could come not from heat death or red giants, but from something simpler, a shutdown, an off switch. Maybe someone, somewhere, decides the simulation has run long enough that it's time to free the memory, clear the data, save the file, or delete it. You'd never know it happened. One instant, you're here. The next, there is no next. Just nothing. Or perhaps not even that. But don't worry, that's not a threat. It's a lullaby in disguise. Because if it were true, it would mean that somewhere we were noticed. Simulated or not, someone once thought us worthy of rendering. And if they end it, well, even books close eventually. Even songs fade. Then there's another idea, just as strange, and perhaps even lonelier. It's called the Boltzmann brain. Imagine the universe, stretched to infinite size and time, empty, dark and quiet, long after everything else has decayed. Particles float in the void, rarely meeting. There is no structure, no galaxies, no planets, but randomness still stirs, and given enough time, particles might briefly arrange themselves into something with order, a star, a molecule, or a brain. Not a brain with a body, just the brain, fully formed, alive only for a fraction of a second, complete with thoughts, memories, feelings, all artificial, but to the brain, indistinguishable from real. It believes it lived a life. It believes it had parents, a childhood, perhaps a love. It believes it walked beneath stars, asked questions, listened to the sea. And then it fades, like foam on the surface of an eternal ocean. Statistically speaking, say some physicists, Boltzmann brains could far outnumber real observers in a sufficiently large universe. The implication? You might be one, right now. That this moment, these words, this breath, is all there is. That there was no yesterday, and there is no tomorrow. Just the echo of a brain dreaming itself into existence. It's a strange kind of comfort, isn't it? Because it means nothing needs to last for it to matter. Even if this is the only moment, a passing flicker in entropy's wind, it was still real to you. You still felt. You still wondered. You still existed. And that's enough. Philosophy can feel cold sometimes, distant, but in the quiet of night, its questions become lullabies. Its paradoxes become pillows. What is the self? What is time? Can a thing exist if no one observes it? Does the moon still rise when no one looks? You might never know. But the beauty is that you get to ask. Even the thought of endings can hold a kind of grace. Because to end, something must first be. There must be presence before absence. There must be a shape before it dissolves. And whether you are a brain in a jar of cosmic chance, a mind in a simulated realm, or simply a person lying under a very real sky, you are here, and that matters. In some distant future, long after planets fall quiet and stars fade out, there may be no minds left, no dreams, no questions. The universe may return to silence. But even then, it will have once been full of minds. Curious, trembling, bright, and that will be written into the shape of its story even if no one reads it. Maybe there are no true endings, only transformations, only handoffs, from star to star, from brain to dust, from question to silence. And maybe even that silence becomes something new. So tonight, let these strange thoughts keep you company, not like riddles, but like wind through tall grass. Let them remind you that the world is wider than logic, deeper than knowledge, and softer than fear. Let them remind you that even the most bewildering ideas can fold into dreams, and perhaps, when you close your eyes, you'll drift not into sleep, but into something bigger, a quiet place where thoughts don't end. They just change shape. And so, we've drifted, slowly, gently, from fire to frost, from distant stars to silent thoughts, and here we are again. Not at the end of all things, not exactly, but at a kind of still point, a moment between wonder and rest, between the questions we ask when wide awake and the ones that wait for us in dreams. It's easy, in the face of so many possibilities, black holes and solar flares, nanomachines and runaway warming, information paradoxes and cosmic simulations, to feel small, to feel fragile, to wonder what any of it means if everything must end. But let's pause for a breath. Right here, right now. The Earth is still here, and more than that, it is still turning. You're on a world that spins softly through space, orbiting a star that still burns just warmly enough. Above you, the sky stretches out into velvet. Beneath you, molten rock moves in slow waves, shaping continents over millions of years. Around you, air stirs gently, trees breathe quietly, and the rhythm of life, imperfect and persistent, continues. Not every end comes with drama. Not every change is a loss. Sometimes, simply continuing is enough. Do you remember where we began? With a question. What would it take to destroy the Earth? But the deeper question, the quieter one, is this. What does it mean to endure? You've heard of cosmic impacts, of fire from space and machines that multiply, of planets freezing into stillness or boiling into steam. You've heard of stars dying, of universes forgetting themselves, of minds that flicker alone in the dark. But for all that, the Earth has kept turning. It turned through asteroid strikes and volcanic winters. It turned through ice ages and extinctions, through chemical shifts and planetary rearrangements. And each time, something lived. Something found a way to persist, to adapt, to begin again. And even if, one day, it all goes silent, even if the oceans leave and the mountains melt and the sky fades to black, that turning will have meant something, because within it was all of this. The warmth of sunlight on stone, the sound of leaves in wind, the spark of curiosity that led us to wonder about our own end in the first place. You don't need to solve the universe tonight. You don't need to carry all its weight. You're already part of it, a piece of its story, a breath in its long, quiet song. And if the Earth were to end, it wouldn't mean it failed. It would mean it finished. And in finishing, it would become part of something else. Dust for new stars, seeds for new worlds, memory carried in the shape of atoms. Right now, in this quiet moment, everything that has ever been is folded into you, into your bones, your breath, your thoughts. You're made of stardust, yes, but also of sunlight and of time and of every story told in whispers before sleep. And maybe that's the real answer, the real protection against fear, not denial, not avoidance, but presence, to be here, to notice, to rest. Because rest is not retreat, it's what allows the world to continue. Even the Earth rests in its way, between storms, between tectonic breaths, between ice and thaw. And you too deserve rest. You've wandered far tonight, through molten cores and frozen oceans, through alien machines and ancient bacteria, through philosophical riddles and stellar deaths. And now you've arrived here. Not at the end of the story, but at its softest part. Let your thoughts float now. Let the questions drift. Let the images of red skies and glowing nebulae dissolve into something slower, gentler. The quiet hum of the planet spinning beneath you, the faint rustle of air outside your window, the comfort of knowing that for now, this moment is whole. The Earth is still turning, the stars are still watching, and you are orbiting something fragile and precious. Sleep well, little Voyager. You're not falling, you are home.